Okay, the last part of this unit is, well, first part of this video is erasing this, but the last part of this unit is logistics and carrying capacity. Now, logistics is just a basic fancy way of saying you're using differential equations to solve for carrying capacities for a civilization. Now, let's take a little trip. Now, I took human geography, so we talked a lot about this. Population capacities is basically how many people, organisms, a certain ecosystem, or place can sustain. So, for example, if you had a house, and this is a total example because this this is kind of fishy, but if you had a house, let's say your house had 3 bedrooms in it, well then your carrying capacity is probably about 6 because you probably could have up to like 2 people per room, maybe. That's like the maximum amount of people that your house could probably hold. If you had more than 6 people, then, and let's say you had 9, and there were 3 people in every room, then some people would get a little mad and think that they had not enough space, so some people would move out, and it would equalize back to about 6. And then what would happen is, let's say you had 3 people in one of the rooms, and then 2 of them moved out because they felt too cramped, and now the person's alone, and now they want to make money, so they're going to put the room up for rent and have a roommate. And as you see, it's going to naturally move back to like 6 people. It's going to go up and down, but it's going to equalize around 6. Now, that is a really silly example because the real-life application of this is just populations in a grander scale than like a house, like the population of the Earth, or like a bacteria population, or population of fish in a city, not in a city, in a school, but in like water. Um, the logistic equation is dy dx, and of course, usually x will be a time, so it'll be like dy dt, and y will be a population, equals k, there's some k, times y, the population, over c minus y. C stands for carrying capacity. I think I called it population capacity either. Earlier. It can be either. That's the amount of people, organisms that it can hold. So dy dx equals ky times the carrying capacity minus y. Also, sometimes you might see this written as like ky over c, 1 minus y over c. And what this basically is, and of course you won't see it in this messy form, but it'll basically look like when you're plugging in numbers, if the first thing is a 1, then this is the carrying capacity, and the first thing, if this is not a 1, then you get it. So, let's do a quick example, and you can then use these questions. I feel like I don't need to go over this because a lot of the questions I'll ask you is about, like, when is it increasing? In that case, you would just check when it's positive and things like that. So, I'm just going to do a quick little problem that has to do with this. Um, It says the rate of growth in the fish population living in a pond is jointly proportional to the number of fish present and the difference between the sustainable population or carrying capacity and the current number of fish. If the carrying capacity is 200, then you're going to get some k value times, well, we'll call the fish population f. So df. I will do dt. And so it would be k times f times 200 carrying capacity minus f. That right there is a logistic equation, and if you had, if a question said, what is the carrying capacity of this population represented by this, you would say 200. However, sometimes it'll say something like, wait, no, that was wrong, sorry. This is the same thing, although it can be a little confusing at this point because, once again, as I argued before, 200k and k are the same thing, but we'll just leave it there for right now. As you see, I just pulled out the 200, and I got 1 minus f over 200. The carrying capacity is still 200. And if you drew this out, you would see that there was kind of like a horizontal asymptote that went to 200, and that's y, because you get that. If you wanted to then find the, you could do all the differential equation stuff, although you might sometimes have to do like Euler's method to get an accurate number, but yeah, it looks something like that. However, if k is some number, let's say k equals 3, and you get 600 f equals 1 minus f over 200. Well, this actually gets a little confusing because you don't know what k is at this point, so it's like you don't know that k actually is only 3. K doesn't actually equal 600. But yeah, I mean, I'm trying to think of other things you do with this. There's just a lot of story problems, but the story problems often will relate back to just what we did earlier in this unit, which is differential equations and finding what the original equation is, and then plugging numbers in. I think it's really all I have to say about this. I feel like, oh, and then also I should point out that this unit is also going to get into slope fields again. However, the slope field, I will show you really quickly. Move the computer. Whoops. I'll show you really quickly. The slope field, as you can notice from these slope fields, this is actually for this exact question, they kind of all flatten out when y equals 200. That's because the carrying capacity is 200. So the question says, sketch the solution that passes through these conditions as 0, 10. Well, that would mean that the population started at 10. But because the carrying capacity, aka what the natural population is going to go to, is 200, it's going to go up the slope field and then flatten out at 200. So it's over, it's going to flatten down there. I feel like it's really all I have to say about that. I mean, the slope field things is kind of just a review. You might want to look back. And the slope fields, you're just going to kind of do a little more complicated slope fields, but they're pretty easy. And that's the differential unit.